Hello everybody, this is discrete structures and optimization. We have completed 4 problems. Now we'll see the 5th problem. This is the formulation of an LPP problem. So let us see how we can do it. I'll read out the problem. A housewife wishes to mix two types of food F1 and F2 in such a way that the vitamin contents of the mixture contain at least 8 units of vitamin A and 11 units of vitamin B. Food F1 costs rupees 60 per kg and food F2 costs rupees 80 per kg. Now, food F1 contains 3 units per kg of vitamin A and 5 units per kg of vitamin B, while food F2 contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. Now formulate the problem as an LPP to minimize the cost of the mixture. Now we'll try to form the LPP. Okay, so here we have the two types of food F1 and F2, and then they are telling that the vitamin contents of the mixture should be 8 units of vitamin A, 11 units of vitamin B, which is the constraints. Then food F1 costs 60 per kg and food F2 costs 80 per kg. And also they given that food F1 contains 3 units of vitamin A and 5 units per kg of vitamin B. Similarly, for food F2, they are given the units for vitamin A and vitamin B contents. So from this, we have to first find out what are the decision variables. So x and y we need to find out. So what could be x and y? So what is x and y? See here, they have to find out the minimizing the cost of the mixture. So cost of the mixture means that is the two foods F1 and F2 are mixed. So when F1 and F2 are mixed means then the amount spent for the food items, that is for F1 and food F2, should be minimized. So here you have to take the x and y values so that the cost for this food is minimized. That means you have to take F1, how much kg of F1 we take, how much kg of F2 we can take. Okay, so that's how we can't take vitamins, because here vitamins are given no least 8 units of vitamin A, 8 units of vitamin B, but it does not come in the cost. So we need to formulate as the cost of the mixture. So when you have a mixture means we have to take the corresponding food only. So food F1 and F2. So food F1 and F2 we take the as x kgs of food F1, y kgs of food F2. So x becomes the x is the number of kgs of food F1. Okay, and y be number of kgs of food F2. So these are the decision variables. Okay, so now we have to minimize the cost. So when we have to minimize means also we'll write the function, that is minimize, let's say z equal to, so we have taken x kg of it for one F1 and y kg of F2. So then we have to find out the minimizing, the objective function would be like the food cost 60 per kg and food F2 cost 80 per kg. So z will be equal to 60 into x, because you are taking x kgs of food F1. So 60x plus 80 of F2, food F2. So 80y. So this is the objective function, that is z is equal to 60x plus 80y, which is the objective function. Next we need to write the constraints. So such that, okay, so what are the constraints? Here for to know the constraints, we need to form a table, that is food F1 and then food F2. There are two food F1 and F2, and each food they have vitamin A and then we have vitamin B. So here food F1 contains 3 units of vitamin A and 5 units of vitamin B. So F1 contains 3 units of vitamin A. So F1 will be having 3 units of vitamin A and 5 units of vitamin B. Food F2 will have what? Will have 4 units of vitamin A and 2 units of vitamin B. Now, what is the constraint? They have said that the mixture should contain, that is the mixture should contain at least 8 units of vitamin A. What does at least mean? At least means it should be greater than 8. Okay, any mixture you take should be, vitamin A should be greater than 8 units, and vitamin B in that food should be, mixture should be what, it should be more than 11 units, 11 units of vitamin B. So that is the constraint. Okay, so here for vitamin A should be, any mixture vitamin A should be what, should be greater than 8 units, vitamin B should be greater than 11 units. Okay, so keeping these in mind, we'll write the constraints. So how can we write the constraints? Using the x and y. So in food F1, see, we have to write the minimum, that is the least cost, at least you should have 8 units of vitamin A. So how will you get 8 units? So 3 units of F1. So 3 in x. So x is the food F1. 3 units of x1, x plus 4 of y, plus 4 of from food F2. So 3x plus 4y should be what? Should be greater than or equal to 8. Next, 5x plus 2y should be greater than equal to what? Should be greater than equal to 11. So this is the constraints. Okay, so x and y should be what? Should be greater than equal to 0. It should not be 0, it should have some value. So should be greater than 0, should be greater than 0, it should not be 0. So it should be xy will be greater than 0. Now we have formed the LPP, like minimize z is equal to 60x plus 80y, such that 3x plus 4y greater than equal to 8, 5x plus 2y greater than equal to 11. So now with these we will try to solve it. Okay, now we're going to solve as we done the regular LPP problem. Here we have this two lines. Okay, 3x plus 4y equal to 8. So by the graphical method we will solve this, and where you have to put x is equal to 0, then 4y will be equal to 8, then y will be 8 by 4, which is equal to 2. So the point will be 0 comma 2. Next you put y equal to 0, 3x equal to 8, so x is equal to 8 by 3, which is equal to 2.66. So it will be 2.66. Hence the point will be 2.66 comma 0. Next line, 5x plus 2y equal to 11. So again put x is equal to 0, then 2y equal to 11. So y is equal to 11 by 2, which is equal to 5.5. So this is the value. So the value will be 0 and 5.5. Next you put y equal to 0, then 5x will be equal to 11. So x will be 11 by 5, which is equal to 10 and 10, so 2.2. So this value is 2.2. Hence the point will be 2.2 comma 0. So we have found out the points. Okay, based on the constraints, we find the points. Now we have to find out the feasible region. So how to find the feasible region? To find out the feasible region, we need to know the boundary points. To find out the boundary points, we have to check the other condition. See, we taken 3x plus 4y equal to 8 and found the values. Now we have to take 3x plus 4y greater than 8. Okay. Now when x is equal to 0, so write the condition x is equal to 0, y should be greater than 2. So y should be greater than 2. Next, when y equal to 0, x should be greater than 2.66. Similarly, write for this line also. So when x is equal to 0, y greater than 5.5. And then when y equal to 0, x will be greater than 2.2. So these are the conditions. So based on conditions, you can arrive at a conclusion. What conclusion can I arrive? See here. See, y greater than 5.5 and y is also greater than 2. So can tell which value will we take. So here we will take this value because y greater than 5.5 will be definitely greater than 2 also. So y greater than 5.5 and y greater than 2. So both of these should be satisfied. So if it is 5.5 means when it is 6 means it is y greater than 2, it is this condition is also satisfied. So we can to take this point. Next, x greater than 2.66 and x greater than 2.2. So which one we will take? See, x is greater than 2.6 and x is greater than 2.2. So which will take? This is the greater value. So we will take this one, this value, because x when x is greater than 2.66, it will be also greater than 2.2 only. So this conditions are satisfied. So this condition is satisfied. So which will point will take? Will take x is greater than 2.66. So we'll take these 2 points. So in the graph we'll have to plot these points. These are in the feasible region. Okay, now we'll draw the graph. Okay, we have written down the points here. I will draw the graph. Here for the slide 0, 2. So 0, 2 is this one. So 0, 2. Now 2.66 and 0. So 1, 2. So 2.66 and 0. So 2.6 will be this one. So 2.66 and 0. So draw the line. Okay, this is what? This is 3x plus 4y equal to 8. Next, the point is 0 and 5.5. So x is 0, 1, 2, 3, 4, 5. So 5.5 be here this point. So this is what 0 and 5.5. And another value is 2.2 and 0. So 2.2. This is 2.2. Okay. This value is 2.2 and 0. So join these two. Okay, goes through this point. Okay. So these two are the lines. Now we have to find out the feasible region. We have found out now. We found out that which are the points we have found in the feasible region. So x greater than 2.6. So 2.6 should be greater than 2.6 and y should be greater than 5.5. X will be 2.66. So which is the point? 2.66. 2.66 is this point. Okay, this point. So this is the boundary point in the feasible region. This marks this point. Next, we found that we found is y greater than 5.5. So 5.5, that is 5.5 and y. So this is the point. So 0, 5.5. So this is the y is y 5.5. So this we have to mark here. So this is also a point in the boundary of the feasible region. So this is point. So we just mark up a point here. We mark it as A, and this is B. Now we have to find out this value because this is also in the feasible. This above. So it's above. All these values conditions are above, right? See, all these conditions values will be greater than or equal to 8. So this condition is x is greater than 2.6, y greater than 5.5. Hence, here we find that it should be above 5.5 and above 2.66. So it will be in this area. So this is the feasible area. Okay, this is the feasible area. Okay, now we have found out the 2 points, but there is another point here, that is the point of intersection point between these two lines. So if we find out that point, we can find out what is the most feasible solution. Okay, so first we can find out the intersection point. We have to find out all the two lines. So what are two lines? That is 3x plus 4y equal to 8, and then 5x plus 2y equal to 11. So when you solve this, you can find out the x and y coordinates, and then which is this point. Okay, so first what I'll do, we'll multiply this by 2. So 2 into 2 will get 10x plus 4y equal to 22. Then 3x plus 4y equal to 8 will be first equation. So we'll try to solve this. So subtracted So we'll get 7x equal to 22 minus 8 will be 14. Okay, so x's will be 14 by 7, which is equal to 2. And substitute x in 2. So 5 into 2 plus 2y equal to 11. And then 10 plus 2y equal to 11. So 2y equal to 11 plus 10, which is 21. So y equal to, it is minus, okay. So 11 minus 10. So 11 minus 10 is what? 11 minus 10 is 1. So 2y equal to 1. So y is equal to 1 by 2, which is 0.5. So the point is 2 comma 0.5. So value of this one is, I'll just take is as c. Okay, c point is 2 and 0.5. So this is the value. Next we have to find out we have all the points in this feasible region. We have found 3 points, that is A, B and C. So in the boundary only we have to find out the points in the feasible region, and then we have to substitute the value in the objective function to find out the minimum cost. Okay, see what is the objective function? Objective function is, say, minimize z equal to 60x plus 80y. 60x plus 80y. So now substitute the value here. See, minimize. So z equal to 60x plus 80y. So there are 3 points. So z of a. So what is the a value? A is 0 and 5.5. B is, B point is 2.66, right? 2.66 and 0. So 2.66 and 0. Then C point is what we have found now, that is 2 and 0.5. Okay. Now we'll first find out for z of a. Z of a is what? That is 60 into 0, that is 0, plus 80 into 5.5. So what will be the value? So it is 440. So z of a is 440. Now z of b. What is z of b? That is 60 into x, that is 2.66, plus 80 into 0. So what is this value? So its value will be 266 into 6. So 159.660. So this is the value of z of b. Now z of c. So this value, it will be 60 into 2 plus 80 into 0.5. What is 60 into 2? 60 into 2 is 120, plus 80 into 0.5 will be 40, is equal to 160. So you find that we have three values, that is 440, 159 and 160. So minimum value you have to take. Minimum value if you see, it's not 440, it will be 159, 160. But here, though it is equivalent to each other, as it's 159.60, this is 160. So they are nearly equal. But which point we have to take? We have to take only C point. Why so? Because here we have value that is 0. Okay, should be greater than 0. We can't have a quantity, x or y quantity can't be in 0. Quantity should be some value, right? So we can't take this value, so we have to take only this value. Hence the value of x will be 2 and the value of y will be 0.5, and the minimum is cost, and the minimum cost will be 160 rupees. Okay, so this is the feasible solution, this is the minimum cost. So this is the way you have to do we have to formulate the LPP and do the problem by the graphical method. So it is a simple method only, but we have to have the patience and mark the values correctly, and then find out the objective function, substitute the values, and you have to derive the correct value, It gives the minimum cost. I hope this is useful to you. If you have any doubts, please write in the comment section. This is regarding preparation for net set exams. So that's why I have not drawn in graph and all. So in question competitive exams and all, you will be given only a ball pen and one sheet of paper. So with that you should be able to get the answer. So that's why I have drawn it in a rough manner. Okay, so if you have any doubts, can write to me with this email ID, that is it is braji10@gmail.com. So if you want any notes for the exams, net or set exams, paper 1, paper 2, please write to this email ID. Can provide the notes. Thank you.